Hey guys, how's it going? Welcome to another episode of Ferris Does Whatevs. So, a little context. I'm between jobs this week. My last day at the last company I worked at was on Monday, and my first day at the next company I'll be working at is on Monday. In the meantime, instead of relaxing and enjoying most of my time off, I've been a bit stressed about taking my Norwegian language tests, which should hopefully have gone well. I just finished the last test today. Like yesterday, I did a listening test and a writing test and a reading test, and then today I did a spoken test. And I think I did well. I'll know in a few weeks. But if that goes well, then I can apply for permanent residence in Norway, which would be really nice. Anyway, enough about that. The point is, now I finally get to enjoy the rest of this week off. So I really wanted to just kind of work on something random, and I've got a couple things in the works. Obviously, we can always do emulator stuff. I've been working on some stuff for revision, which should be pretty cool, but I can't really show too much of that because we're doing some new stuff that I don't want to give away. So I thought we would just work on a project that I actually started a couple weekends ago just for fun. As a lot of you guys know, I like StepMania, this game where you listen to a lot of weeb trash music and push arrows, hopefully at the right times and the right arrows. And I started making my own server for this because StepMania Online servers went down, it seems. I don't really know what happened, to be honest. I haven't really played this game heavily for a couple years, actually. And then me and a few buddies of mine just kind of got back into it recently. We actually found some like off-the-shelf servers, and one of them we set up on my buddy's rig, so we can actually play online anyway, but I just kind of thought, like, that seems kind of like a fun project to do randomly. So I actually started doing that, and I got it working to where I can sort of log in, or at least simulate that, and then get some basic chat working. Or actually, I didn't get basic chat working. I'll get to that in a minute, but you could create rooms, and then, so the idea is normally you'd log in and then create a room, and then a bunch of your friends would join that room, and then you can like select songs and do chat and then play the game. I haven't gotten to any of the interesting stuff about actually playing the game together, just that initial server communication stuff. And I realized already that the approach that I was doing this with wasn't very good. And I'll get to that in a minute, but I thought I could do a lot better with a particular Rust library called Tokyo, which I've been kind of excited to learn about for a long time anyway, because it seems like a really good framework to use to build asynchronous applications with Rust. So I'm kind of excited to dig into that, but we'll get to that in a second. By the way, hi guys in the chat, Darutu, Zakor. Small group today, but I'm happy to see you guys. So the company I worked at previously was called Soprasteria. They're a big French consulting company who has like a big branch in Norway. Actually, a couple branches in Norway. So I worked at the Norwegian headquarters here in Oslo, and I think they also have a branch in Stavanger. And the company I'll be working at starting on Monday is called GraphCore. And they build what they call IPUs, intelligence processing units. So it's very similar to like a GPU, but specialized for machine learning. And I'll be doing a lot of exciting low-level stuff there. I don't actually know specifically what I'll do right away, just because there's a lot to do. And I expect to have a lot of kind of random, a lot of overlapping, or a lot of like random tasks on a lot of different things. So pretty excited about that. And I'll update like my LinkedIn and all that crap when I actually start. But yeah, thanks, Drew. So I want to talk a little bit about the server that I started implementing here. It's not that complicated. Like you have a server, and then several clients through the StepMania UI will connect to that. And again, you can create rooms, and you need to log in to a certain user. So like StepMania Online used to have user registration, where you go on there and register a user, and then once you have that, you can log in with those same credentials with the client. And then again, you could create a room or join a room, and within that room, everyone is either like in the lobby or they're playing a song. So someone picks a song, and then everyone who has that song or like if everyone in the room has a song, then they're allowed to play it. Sort of selects them in all the clients, and then they can start the song. And then I don't really know how the protocol works beyond that, but to get to that point already, we need some kind of like handshaking. We need some kind of user authentication or login, a way to enumerate and create rooms, chat within those rooms, a way to like select songs. And as far as I got was the handshake, and then I don't remember what this SMS thing was. And then, yeah, we'll get to these. Anyway, I got to actually look at this code because I haven't looked at it in a couple weeks. But the packets themselves, so it's pretty low level. It's all TCP, I think. So let me go to the main function here and walk through it just to refresh my own memory. So here's our main function. We have a server name, welcome message, IPv4 header, and the port. Obviously, I plan to make this configurable, but I haven't done that yet. And this just sets up a TCP listener and then creates the server state behind this mutex, and we'll get to that in a sec. But then we just wait for any incoming listeners. And I really like this pattern in the Rust standard library where you do this bind call, and it gives you an iterator of all these listeners. So you can just kind of wait on this on the main thread, or this incoming function, rather. And here we can either match if that connection failed or if that was a successful connection. So if it was, we're going to get a stream from that, and then we can... what I do here is I spawn a thread per connection, and then that will run this sort of main loop, and then the rest is mostly error checking, except at the very end you want to, like, if there's a connection that disconnects and that connection had a logged in user, you want to make sure you log out the user. So that's what this is doing. And then if the connection initially failed to be set up, then you just want to report that as an error. And this isn't that bad. If we go into thread loop, that's where kind of everything actually happens here. And what this does is, so this runs per thread, per connection. Yes, true too. Listener incoming will block until a new connection comes in. So the main thread just kind of sits there and waits for connections in that iterator style. And then, so each thread is going to essentially just loop and try to read packets the whole time. And most of these, again, are blocking. So like these are only going to, this code is only going to execute when there's actually stuff in those buffers. But the idea is that we get the size of a packet and then some kind of command. I think this is called easy packets, which something I never heard before. But the idea is, I think I have a builder here for this. But maybe I don't, because I think I was actually just doing that stuff by hand. But the point is that you just have a very simple packet format. You have the size of the packet, and then you have a command byte, and then you have the payload, and that's it. That's the whole thing. And then everything else happens on sort of another layer after that. So mostly you have a few commands. There's this hello command, and the idea is that either a client sends this to you, and then you send a response back, or you send this to the client, and they send a response back. Yeah, it does sound easy. This SMS thing, what was that? I think it was changed. Yeah, they changed the screen. So this is when a client that is connected to you changes the screen, which screen they're going to look at in the client. So for example, here, if they entered this thing called screen net room, then you want to send them the available rooms so that they can show those in their UI. I haven't done any other rooms here. A lot of magic numbers in here, but that's just how it is as I'm starting this. I don't know how serious this project is even going to be. So this is just literally something I did on a weekend for fun. So not going to claim anything about the maturity of this or whatever. This is just me trying to do some networking code in Rust, which is not something I had done before. And especially trying to make the error handling be okay. And so far, this thing's super robust. So I'm really happy about it, but I'll get to why I don't think this is good design in a second. Anyway, so this just read the size of the command and then look at the command byte, depending on what that is, maps it to a command or does an unknown and then tries to continue. I have these to-dos whenever I continue to try and read the next packet because I don't think this will recover very nicely. And I think that these really should at least, oh no, because I actually, okay, this is actually good because I do read the size and then I read the entire thing into a buffer. So I hope the size isn't super large. But the point is that then we could always skip the packet if we don't recognize it. So, I mean, ideally these continues should be kind of safe. Probably not this one. This one should probably break if it can't read that. But for example, this one where it didn't recognize the command, this should actually be able to just skip the command, and hopefully that's okay. So far in my test, that seems to be all right, at least before I've implemented everything. Anyway, this, yeah, I can explain that and this, and then there's this StepMania Online kind of packet. And the whole thing behind this is that this means that there's StepMania Online specific online play packets within the payload. So then you have sort of this other level where within that you have a command byte and a command sub byte that follows that. And depending on what the command byte is, so like 0 is login, 2 is new room, I think 1 is join room, and I haven't done that yet. Then you would do different things. And so here we get to the actual logic where stuff is actually happening. So what I did is I have this server state struct here. And I tried to make this like the most minimal state possible. Yeah, I didn't say how I figured out the protocol. I didn't really figure it out. I did actually use Wireshark, and I sniffed some of the packets that went back and forth, but I also found a couple resources that just had parts of the protocol documented, and not all of it. In fact, I don't think I found anything that was very useful on the StepMania Online specific packets. But these are just, I think this is, I don't know what this is. Yeah, legacy server, C++ server here. And then this just had some information about the protocol. Yeah, so here's the packets again, where you have the 4-byte size, the command, and then the payload. And then there's different kinds. So there's ping, hello. And I'm just ignoring a lot of those right now. So I took the official client and then this Python server that me and my buddy set up, and just kind of sniffed that a bit just to get the login stuff. And that's also, I haven't gotten to the game stuff. I just haven't gotten that far. Different screens that they could change to. I think one of these is chat. Yeah, chat message here. But then, yeah, they all end with this StepMania Online packet, and that's where all the kind of interesting online play stuff happens. And then, so these are all the client to server commands, and then there's also the server to client commands, which is they're all almost exactly the same, except they start at 128. So you have this high bit set, and they're mostly the same thing. And then what I've been doing to look at the StepMania Online parts is I found there's a .NET server implementation. I'm just kind of looking at that to see what it does. So here, it will send the user to a specific room, so it gives them a command to go to a specific screen, online packet, and then join this room, and then send which players are in there, send some chats to everyone, says whatever joined the room, all that kind of stuff. Now the C# implementation of the server, as well as kind of what I did just starting out, is they basically do the same thing where you have some kind of state behind like a bunch of mutexes or whatever. And in this case, the server state just has some logged in users, and I map this from a socket address to a user because you want to, like each connection is unique, and the connection determines like where the messages are coming from, obviously. And then that may have a logged in user or not, because you can be connected without having logged in yet, for example. But you can always identify a user from the socket address, and you will never not have that when you're processing a command. So I thought that was an okay thing to do. And then the rooms are a hash map from the room name to the actual room. The room has a description and then a password optionally, and then it might have a bunch of users that are logged in that are identified by name. And then the user just has a name for now. I think this is okay. And then I just shove this behind a mutex, and then whenever any of these kind of things come in, any of these commands, it just will lock the mutex and then process the command, whatever it needs to do. So for example, if it's going to log in, then we receive the login. Right now I don't have any actual like user storage or stats or anything, so I just say I check if they're already logged in. But here what I do, like here I lock the mutex. I try to lock the mutex for like a very short period of time whenever I do this. So I look at the server state, and then I see if there's already a user that's been logged in with from the same client, and if there is, we're going to log them out. And then we try to see if this user is already logged in, and we might have an error there if they are, or otherwise then we're going to this says match password because again, I don't have any like user storage, so we're just gonna accept it anyway. And then we add them to that logged in users list, and then that's the result. So once that's done, we unlock the mutex here because this produces a guard when we lock the mutex. And then we actually like report and send the responses to like all the other clients and stuff. And I mean, this works okay. But the big problem with this is that you kind of want a lot of this logic, like whether or not it's sending responses and stuff, to be sort of on a single worker thread, I think, rather than having this and like which packets get sent to everyone all over the place. And because what you find when you do things this way is you end up like locking this mutex kind of all over the place. And you end up with a lot of these patterns where you try to lock it for a very short period of time and then handle it afterwards. And I don't think that this is a very nice way to do this. And already when it comes to like implementing chat, where the chat comes from a specific user, which might be in a specific room, and then you need to find all the other users that are in that room and send that chat to all of those people too. Things like that get kind of annoying when very often you want to like lock this mutex just to see who else is in that room to send that message. You're not actually affecting any of their state other than that. So like, yeah. So then there's also like read-write locks that you could use instead of a mutex, which would at least mean that you don't have any contention to write on that mutex while you're just doing reads. Maybe that's a little bit better. But it just made me think that I think that this is not really going to scale very well. And I think when I look at the C# code, for example, things are kind of all over the place. And I don't really like it. So what I was thinking is that I could sort of redesign this where I would have, again, like a single sort of game thread. And that would handle sort of all the interaction between all of the users on the server, essentially. And I think it's actually okay to kind of... Hey, telepathy. Yeah, exactly. This is the super best server, 2K29 or 2K19. Yeah, I think a design like that would make sense because you would, whenever you're doing the actual work and affecting the state of the server, like the state of the rooms or the state of chat or whatever, like you're always. Let me paint this. Essentially, I want to have like a main command queue. And I want to have different sort of, like a thread will connect, and then maybe they'll put stuff on that queue. And then I don't want them to send anything back to, so like this would be a client. And usually the client will send you a message, and then you want to send messages to the client. So this is kind of the connection between the thing and the client. And whenever anything's going to affect the main stuff or any other thread, what I actually want to do, or any other connection, I want to actually put a command on here. So this might be a chat command or a login command. And what I'm thinking is that those will always go in this main command queue. And then the main command queue can just process those in order. You get like implicit ordering from between this and like other connections just by doing that. And then, so let's say this was like a chat message, this would go in the main queue. And then whenever the main queue got to that message, then it would go and look at the state, and it wouldn't have to lock or unlock any mutexes or anything because it just has the state normally. And it's the only thread that can access that. And it's going to find all the other people that are in the same room and then send commands back to those connections. And the main thing that I'm thinking why this would help is that then the main thread ends up being just this single threaded piece of code that doesn't have to lock any mutexes or anything. And it's just processing commands, like if you imagine like an event pump in Windows or something. It's just handling these ordered events and then changing the state. So everything is kind of interlocked. And then the main thread is also not really blocked by any sort of communication overhead, because this connection part can actually, this is the thing that can handle like processing or parsing the packets that come from the client, and also preparing the packets that's going to send back to the clients. So each connection will sort of have an outgoing queue, which goes to this main thread for the events. Then it's going to have an incoming queue, which comes from the main thread. So it may need to like prepare responses. The other thing is stuff like pings can all happen sort of at this level. So the main thread never needs to touch that. To me, it seems like a good design because you kind of have this sort of unidirectional data flow throughout the whole thing, where like this is kind of split up into two parts, the receive part and the send part. and those are typically disconnected. I'm not entirely sure if this is a good design, to be honest. It's just what I was thinking to implement. And when I was looking at Tokyo, it seemed like they have all the stuff that I would need to do this really comfortably. Duru2 says, is the queue guarded with the read-write lock, or is it lockless? It should be lockless. To be honest, I don't really know. That would depend on the implementation, which is up to me. But if I use Tokyo, I'm just going to use whatever queue system that they give me. So ideally, it's lockless. We don't really know. But at least the idea is that then... I think what originally actually prompted me thinking about this is that with this code, for example, each of these communication threads is always waiting in this loop where it's blocked on reading the incoming stream. But if you want like a chat message and you want to send that to all these clients, all the clients are blocked waiting for incoming reads on their TCP sockets. But you need them to not be blocked on that. You need them to send back the chat message that you just got from some other thread or something. And so you at least need to be able to split sort of the send and receive parts of this, is why I was thinking to have maybe queues at this level, for example, because you don't want any code running on these clients unless there's some incoming message to process or some outgoing message that it needs to process anyway. So it would make sense at least to have those like be blocked in some smart way until one of those two things actually happens. So that's why I was kind of thinking a queue there. And then I thought of a main queue just to be able to have implicit ordering of all the events that come from all the different clients. And again, then none of these would, like the clients wouldn't be able to access any of the global state. They wouldn't even know about it. They would just pump messages and receive messages. And then the only thing that touches the main state is this main thread itself. And I think it would be really nice to have everything just be in a single order there that's enforced implicitly by the queue. That sounds like a good design to me because it decouples everything really nicely and it allows everything to be implemented with, if we use Tokyo, for example, that ends up being green threads. And everything essentially just blocks and won't execute at all or waste any CPU cycles unless it has something that it needs to process. I think that's a very scalable design. I think there's one caveat to this that I was thinking, and that's this becomes really easy to DDoS, and that's because you can just have a bunch of clients connect to this, and they would all, for example, send in like ping commands, and if all those went onto the main thread, for example, like that would be really bad. The other thing that's part of our main state is, for example, how many users are connected. I think that's the one piece of state that we would actually separate because that can be done. That can actually be behind a read-write lock, for example, where an incoming connection could say, okay, we got a successful connection, but maybe we have too many users on the server. We can reject it at this level before it ever even touches this main queue. That would be nice. I mean, it's still possible to DDoS this then, because if the server gets hit by too much and you end up with too many clients doing this, taking up your CPU time, then you're kind of fucked anyway. But like, that's the kind of case I feel like we can't handle at the level of the server anyway. That would have to be handled by some kind of other infrastructure that's kind of out of our hands, I think. I'm not a network guy. This is not my domain, so maybe I'm just speaking out my ass, but that's at least what I'm thinking, and it seems like it sounds good. So yeah, so there's sort of the main state that lives here, and then I think there's the connected user state that would be out here behind a read-write lock, and only this one, or actually, I guess all of these ones would be the ones that would actually write to that. Or maybe there's some interlocked compare and swap on that or something. I don't really know. But I'm actually going to ignore that problem for now anyway, like a max user count, because this is just for me and my friends for now. And at least we would have the ability to implement that kind of feature very easily with this architecture. Yeah, true too. They're a special breed. Hey, Mr. Tom. Oh, did I say hi to Alkama? I sure as hell should have. But yeah, I think this makes sense. Again, the main thing is that it makes it very easy for us to just write very simple sort of unidirectional code as if things were single threaded by just communicating with messages. I guess if you guys are familiar with Erlang, that's kind of what they do. So we just have incoming messages, and then we might process those by producing new messages or something else. And that's like all we're going to do. And then everything becomes nice and single threaded, and all of our state changes in the server are going to be single threaded. I'm probably saying the same things over and over again now. But I like what I'm thinking here, at least. I think it makes sense. Maybe it's over engineering for this kind of thing too, because this is not a big project, but I don't know. It's a good excuse to learn Tokio, which seems to be perfect for implementing this kind of thing. Now, the downside about, at least the way I use Rust, I don't really have very complicated tooling set up for it. And when you're using a framework like this, you kind of have to use, it's kind of all-encompassing because, so Tokio, by the way, I'll share this. Tokio is this Rust framework that's gotten a lot of traction. It's the main thing is it's a big asynchronous runtime, and it does a lot of fancy stuff. So they have a lot of really good documentation on how it actually works. In particular, they have this internal section that I really like because they talk about the actual runtime model. And the whole idea is that you implement things with these futures, and futures are actually pull based. And I say pull with a U, even though they say pull with POLL, which is the same. Like you would pull something that is pull based when you're waiting for an event to come in. I hate that those words sound so similar, but pull based with a U is what I want to say here. They're pull based in that something is going to execute these futures, and it's going to sit there and pull until they're ready. And that sounds like it's going to waste a lot of CPU cycles. But what they do is they make the framework sort of all encompassing, where the things that are actually going to produce the events that the futures are eventually going to need to wait for example, a TCP stream, is also implemented within the framework. So the idea is that a future is going to, when it starts working, or when it calls this pull thing, when a worker calls this pull function, the future is going to try and do as much work as it can. And the idea philosophically is that the only way that you can actually get blocked by doing more work is if you're waiting on something asynchronous that Tokio knows about. So let's say you were waiting for an incoming TCP message, or in our case, an incoming message from the main thread or your client connection. In either case, you want to wait for one of those asynchronous events, and the only way that your thread can, or that your future can actually continue doing work is if one of those things happens. So what you do is you say, like, okay, you pull the TCP connection, or you pull the event queue that you're waiting on. And if either of those is not ready, then a couple things happen. First of all, you're going to return that you weren't ready from your future. And then that way the system knows that, okay, this future is going to wait on some more work. I'm not going to execute this next time I try to execute more work. And the other thing that happens is it keeps track of what gets pulled from which future. So if it knows that particular TCP stream got pulled when it was trying to execute this future, then it knows that, okay, this future says it wasn't ready and it pulled from this particular TCP stream. I'm going to go put this in some queue that I'm not even going to touch until that particular TCP stream produces some new data. And at that point, then I can try to pull the work again. So the whole idea is you have this very, very, actually not that sophisticated. It's pretty basic, at least on a conceptual level. Runtime for incrementally trying to do work. And it won't sit here and pull unless the future has a reason to be pulled, which initially is going to be like whenever the future is sort of, I think they call them spawned. I don't really know this framework very well yet. But you spawn a task which contains a future, I think. And then, so initially it will try to run, and then if it has to wait on a resource, then Tokio will mark which resource it was waiting for and then put it aside, so that if that resource produces new data, then it can pull that future again and try to do more work, try to continue that work. I really like this design because it allows you to write these futures in a really composable way, and they don't really have to care about sort of the outside world. And then you should end up with really lightweight applications with this, because you're never doing work unless you actually have some impetus to push the whole system forward, if that's a good way to put it. Wow, I've been talking for like an hour about this. I haven't even gotten started. But yeah, I like it. I think what I maybe don't like about this design is that, like, again, all the things that are producing values, for example, like the TCP stream class and all that stuff, like that has to be known by the system. Otherwise, you can't really use this. So we can only really do, like, our queue system, for example, needs to be managed by Tokyo. Our TCP stream needs to be managed by Tokyo. If we do file I/O, that's going to be asynchronous. That has to be managed by Tokyo. So it becomes really sort of all-encompassing, but I don't think that there's that many things that we even need to actually do. And I don't think it's that hard to implement something that fits into Tokyo. So for example, if we wanted to add like user stats to this kind of server later, depending on what kind of database it is, they might already have like a database interface that works with the system already. Otherwise, it probably wouldn't be that hard to write one. Desi used last time I checked Tokyo, it didn't work on Windows. Yeah, I haven't actually tried this. I am definitely on Windows, at least right now. So I kind of hope that it will work on Windows. I didn't actually try this. My impression is that it would just work. I guess we'll see. By the way, this little project I'm working on is actually open source. I call it Watch Your Profanity, which is a really funny reference if you know what it is, and if not, I'm sorry, I'm not going to explain it. If you Google it, you'll find just some stupid video that me and my friends always send to each other. Yeah, I might experience some proper disappointment. What I do want to do actually before I get into that, I do want to show the server somewhat working. So I'm just going to run this, and you can see it just says incoming connections. And then I'll run the StepMania client. And I'm just going to like log in here. I know you can't see all of my windows here, but that's just how it is. Actually, can I resize this? Yeah, I can. That's good enough. So I go to options here, and then in network options, connect to me. Okay, so we got the connection to server here, and we received the handshake. And this also is the connection that came in from the client. So now we're connected, and I can go into start game, and I think this will prompt me to log in. So I pick a certain profile, and then I'm logging into this person. I can enter whatever password. And it's going to accept that because it has no knowledge of users. So now it gave me a little welcome message, and this is again handled through chat messages. And it said, yeah, here's a little server message. So subweeb, and then the name of the server, and one user is currently logged in. That's me. So now I can do things like create a room, the best room, and this is all about the best room for a description and no password. And then it actually gets me into that room. Yes, the best room created successfully. I think I can get out of that too. And we can see the best room in the room list. And I can join that, I think, too. Except so I'm sending the join commands, but I don't actually handle those on the server side yet. So that's as far as this project actually is. And already there, when I wanted to do chat messages, hi chat. Here you can see we got the unknown command byte, which is the chat message. And yeah. And already it was implementing chat, and then like, how do I tell these connection threads that they need to send out data when they're waiting for incoming data? That was sort of the impetus of thinking of this other design. So I'm basically planning on scrapping most of this and starting from scratch for this sort of new design. But I think the first step here would actually just be to follow some tutorial code in Tokyo. Did I add this over here? No. Where'd my tabs go? Kirkilly, yeah, it is still going to be a StepMania server. That's still something I want to play around with. But I think the best way to do this actually is just to kind of start a new project here. So I'm actually gonna do this. Make dir old. Or actually, I'll just start a new one here. Cargo new bin. Watch. Actually, you know what? Let's do it this way instead. Get checkout branch Tokyo. And then I can just delete this stuff, I think. Or I don't need to delete it, really. I just go in and start changing stuff. So I think if I go back to Tokyo, and I'm just going to go through the get started. There should be like some hello world here kind of thing. And I think the best thing to do is essentially just copy something like this, where we start again with incoming listeners like this. Because I think the very top level of our code won't change much. And I'm just going to erase most of the stuff we have here because it's all on that branch. So we'll get to some of this other stuff. I think like this easy packet builder might be nice too. There's some read and write stuff that we're probably going to want to keep. But I think most of this is going to go away. We'll probably still want byte order, and we're definitely going to want Tokyo. So add this. Actually, I'll make this alphabetic order. And I guess with Tokyo especially, I see this more and more with Rust stuff. It's really common like Haskell, but they import a lot of stuff in this kind of prelude pattern. I typically don't like this, but I guess this will contain a lot of the combinators for the features that we're probably going to want. And then here, I don't know how much of this stuff is going to be compatible with the standard library. I think most of the stuff, though, like I'm going to erase the server state stuff here. We'll get to that in a sec. Send roomless, I'm also going to get rid of. Send room stuff. Yeah, because here, for example, I was doing the send a room screen where you're going to send one of the clients to a particular room. And so you already need to lock the server state, or at least read it, to get all the different rooms. And then you need to find the right room and send it to all the players and send the join message to all the players through the chat. So, yeah. Is that deprecated in 2018? I mean, that's great because I don't want to do that. So I actually do, I think, a pretty bad job, actually, of keeping up with Rust. Should we do... Yeah, we're going to get rid of this and comment this out for now, too. I have a feeling that will still be useful, but we'll get rid of that for now. Yeah, this whole thread loop thing, I think we're just getting rid of. Yeah, I notice that more and more. Like I get worse and worse at keeping up with like new Rust features or changes in Rust, like reading This Week in Rust, for example. I just get my head down in so many projects and I just forget that the Rust community is solving all my problems at the same time. So anyway, get rid of this too. Most of this should stay the same, except TCP listener now. From there, like this, and I'm not really sure what our result type is going to be here. We'll get to that too. Yeah, I'm super old school, using Rust from 2018, but not the 2018 edition. We'll do IPv4 adder dot parse, and I don't like to unwrap here. I'll do this for now. And I'm literally just copying the tutorial stuff here. So actually, because we want to make the listener here. So we want TCP listener here. Yeah, it's so perfect, software. Yes, I'm actually 60 because I even mentioned Erlang. That is how that works. I got a buddy who started a games company this last year, and he is so in love with Erlang these days. And I'm liking what I'm hearing. Not gonna lie. I'm gonna bind this to the address. And is that not what I imported up here? Oh. Dir. Yeah, also, I'm so bad at handling multiple error types in Rust. But again, I'm going to be old school here. In fact, actually, I think I could just do E here. So I'm actually going to do, let's see what this does. Yeah, because we need to change how this is written too now, because we're going to create a future, which is going to be something that does work, that like waits for incoming connections, and then we'll probably spawn other tasks. And then we want to spawn that, and we want to run that with the Tokyo runner. So we're going to do Tokyo run with the server. I don't mind calling this server. Let server is listener.incoming. And I'm guessing this is like I think they call them streams, which is like a feature that can produce several values over time. And we're going to, I like to put this on another line when I do map error. That's another thing I really need to do is use ePrintline for error stuff. And then for each on the stream. Split this into the reader and the writer. Let's use, how does the client connection even fail? To be honest, I don't know, but I know that it can. So, I don't know. Now, I need to look up documentation here. Like API documentation. Get this nice Rust shiz. So we have a TCP because listener and incoming gives us this incoming iterator. I want to see what type this ends up giving us. TCP stream, that's what I want. And then we can go back here. TCP stream. I like how I just ninja peeked at the source there. So the stream, like that should have already been connected here. Because like if we do connect feature, I'm guessing there's a lot of these where we get some kind of feature like this. The peer address, for example, we need to read. And I think I'm actually going to call this stream, which is what I called it down here. So now I can do like the same thing where I do let client adder is stream.peer adder. And this should just work if I do that. Because I'm pretty sure we're going to need to do a lot of error mapping here. Oh no. Was this an IO result? The core result even. Because the signature of these functions of these poll functions should be like a result of whatever the OK value is, and then the error or OK, and then either not ready or the actual error, whatever that type ends up being. Oh, this is actually up here that this is happening. Does that work for me? Yeah, I guess here. That's actually probably the error that we're seeing. Yes, that's the main error there. And that just allows us to error out here with this result. You know, this is not really an IO result, so maybe that's shitty. Actually, can I do this nowadays? Not specify the error type? No, I think I need to do the actual type. Because I was thinking I could do this type of error. No, I'm overthinking this right now. Anyway, I'm a little confused here. Because I don't understand why this wouldn't work. Or what kind of error type this is supposed to give me. Or Tokyo error. Because I would imagine this for each thing here on a stream. So I'm going to go back. Tokyo. Oh, we have this here, actually. That's nice. It's like for each. It's a function which gives us. Yeah, use into feature where item is this and the error is the self error. It should be correct for us to do okay there. I'm pretty sure in Tokyo, the future. Would that be in Prelude? Yeah, it is. The poll method, that's what I'm after here. Yeah, async item, so in this case. That was a unit, so maybe. I'm a bit confused at the type signatures here, actually. You know what I'm going to do for a second here? I'm just going to do this. Until I can figure that out. Because I want to do this same kind of behavior here. And for now, I'm just going to run this. So we can see that will work. It'll just drop the connection immediately, of course. And Tokyo has a lot of dependencies, as we can see. So this will take a minute to build. Oh, really? It couldn't parse the address? That I did not expect. That's funny. Yeah, maybe they needed the port as well. So then in that case, we can just do this. Yeah, okay, that seems to work. And then, so we're listening, and then just want to create this thing here. Normally I just let the StepMania client run because Doesn't crash at least. So network options, connect. We got a connection. And then it says connection to server drop because immediately the client connected, and then the code here just says okay, which drops the connection. So that's what's happening there. So that's great. That appears to work so far, at least. Well, at least that seems to work on Windows. So I think what I want to do with this then is we want to split this stream after the client's been connected. And in this case, I spawned a thread for doing the reading. But with Tokyo, you don't really do threads. Like, you expect the executor to ideally use a thread pool, for example, if that's available on the host system, or if that can be implemented on the host system, rather. But the idea is that you always work with these features, so you want to spawn more tasks with other features. So I would have one feature, or I guess one stream for the reader, and then another one that would wait on some queue for the writer. And then I think that's what I want to do, and then end up spawning both of those. I think that's how this is supposed to work. Not entirely sure though, because I've never done this before. So I guess the easiest thing we can do to start out with is just see if we can read anything. If we can read a packet, for example. So that shouldn't be too hard. We'll ignore the writer and do the reader. Is stream.split. And I'm going to do this, actually. Reader is reader. So we should get some bytes here. Oh, this is kind of cool how you can chain this. So here, this is the easy thing that we can do for now. And I'm going to do this too. And yeah, at the end of this, we want to Tokyo spawn this. And then I don't think you need to do and then here. I think you just do this like in the for each, but I'm just following this example here. Because we don't expect this to produce any more values because we have a unit here. So then this is just nothing here. And maybe this is how it disconnects or something. Otherwise, we can handle errors like this. Here we also need to do produce okay. And here we're gonna error with that error. I guess this is nice because this is kind of like try catch finally. Whatever this result was. Yeah, I think this example used a particular codec that's in the Tokyo library. I don't really know what that means. But I think I don't know why you would need this. We have a TCP stream and call split on it. What does that give us? From what I've seen, I think it looks nice. But I would need to see something of proper scale built with it too. I've seen a lot of frameworks that look like this though. It can be a bit verbose, and one of the things that I don't like about these kind of frameworks is you really have to learn sort of the language of the framework. You're essentially writing code in a DSL that the framework is allowing you to write in. And if you're really very familiar with that, this kind of thing becomes very fluid. If you're not, like I'm not right now, you end up kind of digging a lot, and that can be really frustrating. So split is not here, so that must come from something else. I don't really know what that's from. Let's look at what this implements. I think IO split. Oh, async read is what it is. Really? There we go. Is this a read half or a write half? I like to go really deep with this stuff. If you guys hadn't noticed, like look at the specific types and how the stuff is built up to understand it. I feel like I move kind of slowly through this kind of thing when I'm first starting out learning this stuff, but I feel like I get to kind of fundamentally understand it at some point, then it just clicks. You can unsplit it too if you give it the right half. That's kind of cute. I guess to read half of T, and I don't know what that would give us in this case. So you have a codec. I don't really know what the codec is in this framework. Should probably actually find some docs about that. Delays for encoding and decoding frames. Hey, Dark Second. Probably not going to go for too much longer here, by the way, guys. Dark Second, thank you so much for the sub. Really appreciate it. Especially for the nice streak. It's great. Help us transform a stream of bytes into a stream of frames. Examples of byte streams include TCP connections, whatever. The rest streams are easily identified because they implement read and write. Suppose forms of frame messages. This is a delimited message. Message ends with a whatever character. Okay. So I'm guessing then. Let me see here. Must be written. Hey, whatever. Wrap around a codec that implements automatic buffering. Both stream in a sync. I guess probably the idiomatic thing here would be to have a codec for these easy socket packets. Because I think the whole point of this, if I've understood this correctly, is that whatever you get from here should ideally be some complete set of something. So this would only concern itself with like entire frames. In this case, a frame could be an easy socket packet or something. Not entirely sure. Because like this example that I found, this Hello World kind of example, where was that? I don't remember where I saw that now. Hey, it was here. So this is print each packet example. And so this used this bytes codec. And I don't know why you would need that, or if you would need a codec at all. Ships bytes around. Simple encoder and decoder. Let me see here. What was the error that we actually got here? Because I skipped the codec thing because I missed it the first time when I wrote this, and I'm kind of just thinking like, why do we need the codec? Where are the types not lining up? That says we need that. No method for each for type. Right half. Oh, did I just mix up the order here? Don't think so. Not even if I do this. It's still right half. Why does that give me right half? This stream does split give me. Read half and right. Okay, so the right half is the second one, so this example might be wrong. read half, whatever. Needs to be stream and iterator. So maybe that's all it is, that a codec. Because let's see. Turning features. Frame to and from bytes. So because what I don't understand is why we can't just look at these bytes directly. Why do we need a codec? I mean, this I can understand. Like this thing here. Since all bytes are buffered until a line is found, it's wasteful to search for /n at the beginning of the buffer every time data is received. So like our and then should just be able to take a whole frame. So again, having a codec for these easy packets should be what we do here. But I still don't feel like we need those for just starting this out. But maybe we do, just because the types expect it. Like we can't do and then without creating something with these particular traits implemented, and a codec would implement those. Maybe it's just that simple. Because it's framed struct, so unified stream and sync interface. Coder decoder. So you would create a new frame. So I think the idea is that we would have a stream from this read half thing. Send sync read half should implement. What's this again? Stream and sync? No. I'm getting lost here. What I'm not seeing is what's actually going to call these, and why we're getting an error here specifically. So we know that this is our read half, and we're trying to call for each on it, but for each doesn't exist on read half unless the particular implementation of read half implements these traits. I think this is what this error is trying to tell us. And so we need, so I guess we just need some kind of, to use the for each method, we need some kind of type that implements these. Because it's stream. Yeah, here, where Yeah, admittedly, I'm a bit lost here. But I've already been streaming for like an hour and a half. So I think I'm actually going to go for now. And maybe I'll dig into this more and I'll stream another time with this project. Maybe not. We'll see. Anyway, thanks guys for hanging out, and I'm going to see you next time.